Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. All right, children, a quick recap of recap meaning I'm not telling you the getting into the explanation, but just the headings, what we saw in the last class. So we understood the meaning of rational numbers. What are rational numbers? What are irrational numbers? What are irrational numbers? Rational and irrational numbers together are called real numbers. Then how to insert or how to find rationals between two given rationals. How to find rationals between two given rationals. How to insert rationals between two given rationals. And we also saw how to identify that a P by Q has a terminating decimal expansion or not, or not meaning or a non-terminating repeating decimal expansion. Repeating decimal expansion. So this is what we saw in the last class. We started with the, the understanding of natural numbers, whole numbers, integers, then rational numbers, irrational numbers. Rational numbers and irrational numbers together are called real numbers. And after that, we understood how to insert as many rationals between two given rationals. You can insert 2, 3, 4, 5, 10, 100. Okay, so you can insert as many rationals between two given rationals. So we saw that, and we also understood how to find if a P by Q has a terminating decimal expansion or a non-terminating repeating decimal expansion. Now the thing is, one thing which I have to make clear to the class is that these presentations are still not ready. That's why I've not shared it with you. So you'll be wondering that I don't have material to study. You've been explaining, but I have nothing in my book to study. It's not ready. So children, I'm just working on it. Tomorrow, positively, I'll share all the contents of last class, that is last session and today's session. All the contents of the previous session, that is session 1 and session 2, will be shared with you by tomorrow afternoon. So what you have to do is, once you receive that from me, maintain a notebook. Maintain a notebook for this class and write out all the contents in that notebook. You don't have to wait for your school to give you the textbook and all that. This book is more than sufficient for practicing. So you have to keep aside a notebook for this class. Now, session 1, you had only been listening. You did not write anything in session 1. Now, today's session also, I'll be talking about many things where you will not be writing. You'll only be trying to understand. That's because the presentations are not ready. Once the presentations are ready, you will be, I'll explain something and then you will also write it out in the class. So the old students know that, the new students are not aware of that. So you have to just bear with me for 2-3 classrooms and then you will understand the nature of the class. Okay, so session 1 and session 2's contents will be shared with you tomorrow, by tomorrow afternoon on WhatsApp. Once you receive that, start writing all that in your maths notebook. That is the notebook which you keep aside for this class. Write out everything in that. And it is more than sufficient if you practice the same thing. Apart from that, you will get assignments. There'll be some tests which I conduct online. So all that you will get to know as we progress with the classes. All right, children. So let's begin today's session. Yeah. Okay. So simplify the expressions. The first one is root 11 plus 3 root 11. Now this is exactly like simplifying x plus 3x. What's the value of x plus 3x, children? What is x plus 3x?
4x.
4x. X plus 3x is 4x. So here root 11 plus 3 root 11 is equal to 4 root 11. I'll tell you how we get that. So what is common between 3 root 11 and root 11 and 3 root 11? What's common? Root 11 is common, right? Root 11 is common, right? So you'll get 1 plus 3 in the bracket. So which is 4 root 11? 4 root 11. See, I'll show you again. Root 11 plus 3 root 11. Okay. Now what's common between these two? Root 11 is common. Take out the common factor. So here if it is root 11, somebody's mic is enabled, disable your mic. So here if it is root 11, it is 1 root 11. There's 1 here. So 1 plus 3. 1 plus 3 in the bracket. 1 into root 11 is root 11. 3 into root 11 is 3 root 11. So 1 plus 3 is 4. So 4 root 11. 4 root 11. Or you don't have to take all this common and all that. You can just do it like root 11 plus 3 root 11. Okay, so it's like x plus 3x. This is like your x. X plus 3x. This is x plus 3x because root 11 is x. So what is x plus 3x? 4x. So it's 4 root 11. 4 root 11. Same rules of algebra. Same signs. Add and put the same sign. Different signs. Subtract and put the sign of the greater number. Same rules. So now children tell me what is 2 root 11 plus 5 root 11? What is 2 root 11 plus 5 root 11?
7 root 11.
7 root 11. 7 root 11. Very good. 7 root 11. So it's like 2x plus 5x. 7x. 7 root 11. Now tell me what is root 11 plus root 11 plus root 11?
3 root 11. 3 root 11.
3 root 11 because it's like x plus x plus x. What's x plus x plus x? 3x. So similarly 3 root 11. It's like x plus x plus x. So it's 3 root x or 3 root 11. Okay. Now what is cube root of 11 plus cube root of 11? This is also like x only. This is also like x. So it is 2 into cube root of 11. Exactly. 2 cube root of 11. 2 cube root of 11. Is that understood? So what will be? What will be? Yeah, what will be 4th root of say like 10 plus 4th root of 10 plus 3 into 4th root of 10. What's the result?
5 4th root of 10.
Yeah, who's that?
Anirudhan.
Very good. 5 into 5 4th root of 10, or you can say 5 into 4th root of 10. Both are the same. 5 4th root of 10 because there's 1 here. There's 1 here and there's 1 here. So 1 plus 1, 2. 2 plus 3, 5. 5 4th root of 10. So now what have we been doing? We have been adding like surds. These are all like surds. Like surds. Like you say, like terms. Like terms. Okay, like terms. Now, when you have 2x and 3x, they're like terms. So you add them and you say it is 5x. But what is 2x plus 3y, children? Are they like terms or unlike terms, 2x and 3y?
Unlike terms, ma'am.
Unlike terms. What is the result now? What is the result? What is 2x plus 3x? Can you add them?
No, ma'am.
No, they are unlike terms. You cannot add. They're unlike terms. But can you multiply them? 2x into 3y?
Yes, ma'am.
Yes, ma'am.
What's the result?
6xy.
6xy. No, 2 3s are 6. 6xy. 6xy. So the same rules of algebra here. So in algebra, you can add or subtract only like terms. So now if you have 10x square y minus 5x square y, they're like terms. X square y, they're like terms. So the result is, what is 10x square y minus 5x square y?
Ma'am,
5x square. 5x square.
5x square y. The algebraic factors, they come as they are. Algebraic factors x square y, they come as they are. See, when you add or subtract, see, if you have 10x square y plus 2x square y minus x square y plus 20, sorry. Okay, so plus x square y, supposing some plus 20x square y and say like minus 11x square y. So in the result, x square y will come as it is. X square y will come as it is. You will only simplify the numerical coefficients. So what is 10 plus 2? 12. 12 minus 1. See, if there's nothing, there is 1. 10 plus 2, 12. 12 minus 1, 11. 11 plus 20, 31. 31 minus 11, 20. So 20x square y. So when they are like terms, you will write that algebraic factor as it is. X square y is the algebraic factor. You should write it as it is. What will you simplify? You will only simplify the numerical coefficients. So that 10 plus 2 minus 1 plus 20 minus 11. You must simplify that and write that as the coefficient of x square y. So 20x square y is the answer. So how many ever x square y terms you have? The result will have only one x square y. And then whatever is the value of the coefficients after simplifying. So here it is 20. So 20x square y. Supposing it is 10x square y into 2x square y. What's the result?
20x square y.
4y square.
20
X to the power 4y square.
X to the power of 4, y square.
Y square, correct. Because when you multiply, see, you can multiply anything. Addition and subtraction can be only done with like terms. Only like terms can be added or subtracted. Like terms can be added or subtracted, but for multiplication and division, you can multiply and divide like terms, unlike terms, both you can. But when you multiply, you should multiply everything. You must multiply the signs, you must multiply the numbers, you must multiply the letters. That is the algebraic factors. Everything you should multiply. When you add or subtract, for addition, subtraction, what is the rule? Only like terms. Only like terms can be added or subtracted. And when you add or subtract them, you write the algebraic factor as it is. And you will add or subtract it. That is, you will simplify only the numbers, the numerical coefficients. But when you multiply, you can multiply like terms as well as unlike terms. And when you multiply, you will multiply three things. You will multiply the signs. You will multiply the numbers. You will multiply the letters or the algebraic factors. So here the signs are plus and plus. There's no sign, so it's plus and plus. So plus into plus is plus. So we multiply the signs. Then the numbers, 10 2s are 20, 20. Then the letters, x square into x square is x to the power 4. Then y into y is y square. So you should multiply everything. Everything is to be multiplied. Same rules with irrational numbers. Same rules with irrational numbers. Whatever you have done here in algebra, the same thing can be extended to irrational numbers or surds. You can add or subtract only like surds. Multiplication and division can be performed with any surd. Okay. So now, supposing you have square root of say like 13 minus 5th root of 13. This cannot be simplified because they're unlike surds. They're not like surds. This is 5th root of 13. This is square root of 13. This is square root of 13. This is 5th root of 13. So you cannot simplify them. It's like you have x and x to the x minus x to the power 5, something like that. X minus x to the power 5. They're not like terms. If it is x here, it should be x here also. If this is x to the power 5, this also should be x to the power 5. Some x to the power 5. In the same way, this is square root of 13. Here you see 13, but it is the 5th root of 13. So they're not like surds. You cannot add or subtract them. So if you're asked to simplify the square root of 13 minus 5th root of 13, nothing. You cannot simplify it any further. Like if you have x minus x to the power 5, you can't do anything. You cannot simplify this and write 4 or whatever. You cannot write anything. Like you cannot write this is 4x to the power 5 or minus 4x to the power 5. No. Now, when you multiply, say like square root of 2 square root of 3 into 5 square root of 3. This is multiplying. This is multiplying. Multiplying can be done with anything. But here we have another situation. Surds of the same order, different order. I'll tell you that later. Surds of the same order, same order, surds of different order. So we'll take it up next. We'll understand some basics and then go to this one. Surds of the same order, surds of different order. So now let's try to answer this. Okay, so 2 square root of 3 into 5 square root of 3. Now how do you multiply? Multiplication can be done with like as well as unlike surds. That's the first thing. And when you multiply everything. So you multiply 2 into 5. 2 into 5 into root 3 into root 3. This is how you multiply. Into root 3 into root 3. Now what is 2 5s are 10. What is root 3 into root 3? It is root of 3 into 3. Root 3 into root 3 is root of 3 into 3. 2 5s are 10 into root 3 into root 3 is root of 3 into 3. Now you've learned last year, under the square root, if you have two equal factors, one will come out. You can bring one out. So 10 into, from 2 3s, 1 3 comes out. So 10 into 3, which is 30. Is this understood, children? I'll do it again for you. I'll do the same thing again for you. 2 root 3 into 5 root 3 is equal to 2 into 5 into root 3 into root 3. So 2 5s are 10. 10 into root of 3 into 3. Now, under the square root, when you have two equal factors, one will come out. So 10 into 3. So the product is 30. Children, just give me a minute. There's somebody ringing the bell. I'll just come back. Yeah, children, I'm back. Yeah. Now tell me this one. I hope you understood something. Is something understood, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, very good. Now let's try this. Let's try this one. So it's a product, all right? So when you're multiplying, you don't see if they're like, unlike, don't see anything, just multiply, all right? So now how do we multiply? We multiply the signs first. So plus, minus, minus. See, it's this one into, it's a product. You'll have to multiply these three. So minus into minus plus, fine, so it's positive. Now multiply 2 into 4, okay, or if you want, you can write. You can write 2 into, okay, fine. 2 into minus 4 into, yeah, that's it. 2 into minus 4, okay, into cube root of 5 into cube root of 5 into cube root of 5. Oh, there's a minus here also. Minus cube root of 5. 2 into minus 4 into cube root of 5 into cube root of 5 into minus cube root of 5. Now minus into minus plus. Okay, so 2 4s are 8. 8 into cube root of 5 into 5 into 5. And what have we studied last year in cubes and cube roots? From 3 equal factors, you can bring 1 out of the cube root. From 3 equal factors, you can bring 1 out of the cube root. So into 5. 8 5s are 40. Is this fine, children?
Yes, ma'am.
All of you?
Yes.
Yes, ma'am.
So when you
Yes,
multiply, do not worry about if they're like, unlike, nothing. Just don't worry. But there's something more I have to say. I told you there's something called surds of the same order, surds of different order. You will learn something different when we come there. For now, just understand what I'm saying. So here it's multiplication. So what you do, you multiply the signs, you multiply the numbers, and you multiply the surds. So 2 4s are 8. Minus into minus plus. When you multiply minus and minus plus. 2 4s are 8. Then cube root of 5 into cube root of 5 into cube root of 5. So it's cube root of 5 into 5 into 5. So from 3 5s, 1 5 out. Because cube root, no? So from 3 5s, 1 5 out. 40. 8 5s are 40. Now supposing you had 7th root of 5 plus 14 7th root of 5 minus 3 7th root of 3. What's the result, children? What's the result? Now it's addition. So these are like surds, this one and this one. So you can add, write that 7th root of 5 as it is. 2 plus 14, 16, correct? When you're adding or subtracting, only the numbers, only the numerical coefficients, only the numbers you'll simplify. That third you should write as it is. 7th root of 5 as it is you must write. Like you write x, y, x square y as it is. Only the numbers you must simplify. Only the coefficients you must simplify when you're adding or subtracting. Minus 3 7th root of 3. That will come as it is. Because these two are not like. So you cannot simplify them any further. You cannot simplify this any further. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
Okay, ma'am.
It's like you have 16xy minus 3 x square y. You cannot simplify this. You can multiply them. See, this is subtraction. You cannot subtract them because they're unlike. This is xy. See, how do you make out if they're like or unlike? From the algebraic factors. This is xy. This is x square y. So they're unlike. because the algebraic factors are not the same. So they're unlike. So 16xy minus 3x square y cannot be simplified further. It's the same thing. But you can multiply. If you have to multiply 16xy and minus 3x square y, you can multiply them. 16 into minus 3 is minus 48. X into x square is x cubed. Y into y is y squared. You can multiply them. Okay, it's okay if you have not understood, like it's okay if you've understood kind of 90%, somewhere you have a doubt. So for that, we'll have to take a test. Now I'm going to put up some 15 questions on the screen. Try it on your own and we'll discuss the answers. Then you can evaluate yourself. And if you have any further questions, you can ask me. Okay. In your rough note, children, whatever you write today in your rough notebook, because you don't have the, the classwork of session 1. So don't write in your, that maths notebook. Do it in your rough notebook today. Take down these. You don't wait for all the questions, children. Please start working. Please start working. Don't wait for all the questions. All right, children. So that you can see 15 expressions on the screen. Please simplify them. I'll just get back in 5 minutes. Please simplify them. We'll discuss the answers in 5 minutes.
Completed, ma'am.
Okay, very good. All of you, shall we see the answers?
No, ma'am.
Okay. All right, I'll just wait for a few more minutes, 2-3 minutes, and then we'll discuss the answers. All right. Children, stop working. Stop working. Roshni, tell me the answer with the first one. Roshni. Quickly, you should unmute and tell me the answer, children. Araga, my first one answer. Why no response? Is Roshni there? Is Aragamai there in the meeting? Okay, Sahana. Yeah, you were there, no? What happened,
Ma'am,
Aragamai?
0, ma'am.
0. So this is 1 root 7, correct? 1 root 7 plus 3 root 7 is 4 root 7. 4 root 7 minus 4 root 7 is 0. Very good. Is 0. Very good. Second one, who wants to say the second one? Quickly. Abhishek.
Shall I?
Yes, Swati.
Ma'am, it's 4 root of 3.
4 root 3. 4 root 3. Because they're like terms. See here, root 3, root 3, root 3. So they're like surds. They're like surds. They're like surds because you can see the radical here. Root 3, root 3, root 3. So 2 root 3. So 2 plus 3, 5. 5 minus 1. It's minus 1. 5 minus 1, 4. So 4 root 3. Very good. 4 root 3. Next one. Who wants to say the next one? It's a product. So it's okay if they're like or unlike. Yeah, next answer. Who wants to
60 root 7, ma'am.
How much?
60 root 7.
60 root 7. Okay. So let's see the third one here. Let's see the third one. So how do you multiply? 2 into 3 into 2. Okay. 2 into 3 into 2. Then into root 7 into root 5 into root 5. 2 root 7 means 2 into root 7. 3 root 5 meaning 3 into root 5. See, like, what is xy? What do you mean by xy? X into y. xy means x into y. 2x means 2 into x. Similarly, 2 root 7 means 2 into root 7. 3 root 5 is 3 into root 5. So it is 2 into 3 into 2. 2 into 3 into 2 into root 7 into root 5 into root 5. Into root 7 into root 5 into root 5. So now let's multiply. 2 2s are 4. 4 3s are 12. 4 3s are 12. Okay. So 12 into square root of, you can write all this under the square root. You can write all this under the square. 7 into 5 into 5. 7 into 5 into 5. So from 2 5s, 1 5 will come out. From 2 5s, 1 5 comes out, right? So then it will become 12 5s are 60. So 60 root 7 is the answer. 60 root 7 is the answer. Under the square root, you will have 7 into 5 into 5. From 2 5s, 1 5 comes out of the square root. So 12 5s are 60. 7 remains under the square root. 7 does not come out of the square root. 7 remains under the square root. So the product is 60 root 7. Correct. Sahana is right. Yeah, you can ask me. If I'm not clear, I'll explain again. Got it, children?
Yes, ma'am.
Others? Any questions? Please
Yes,
ask
ma'am.
me. All right. All right. Next one. So it's root 3, root 3, root 3, root 3, root 3 everywhere. Okay. So they are like, so we can add or subtract them. So 3 plus 4, 7. 7 plus 11, 18. 18 minus 6, 12. 12 minus 1. Don't forget this. 12 minus 1, 11. 11 root 3 is the answer for the fourth one. Correct, children? 11 root 3.
Yes, ma'am.
Yes, ma'am.
11
Yes,
root
ma'am.
3 is the answer for the fourth one. Very good. Okay. Now the fifth one. Just a second. I'll just clear this up. Yeah. Okay. Fifth one. Answer for the fifth one. 5 root 2 plus 2 root 2. What is it? What is 5 root 2 plus 2 root 2?
7 root 2, ma'am.
7 root 2 into 3 root 5. See here, outside the bracket, there is 3 root 5. That means into 3 root 5. Now you can multiply. They are not like sets. This is root 2, this is root 5. They are not like sets, but you can multiply them. You can multiply them. So how do you multiply? 7 3s are 21 into under the square root 2 into 5. Under the square root 2 into 5. Because square root of 2, square root of 5. So it will be square root of 2 into 5. Square root of 2 into square root of 5 is square root of 2 into 5. Now 7 3s are 21, square root of 2 into 5. So it will be 21. Now there is only 1 2, there's only 1 5 under the square root. So nobody comes out. There should be 2 2s at least. Then 1 2 can come out. 2 5s, 1 5 can come out. There's only 1 2 and 1 5. Nobody comes out of the square root. So it is 21 root 10. This is the answer. Final answer 21 root 10. All right, children?
Yes, ma'am.
Yes, ma'am.
See, yeah, if it was 7 root 2 plus 3 root 5, you cannot add. 7 root 2 plus 3 root 5, you cannot add because this is root 2, this is root 5. They're unlike surds. You cannot add them. This is root 2, this is root 5. You cannot add. You can multiply them. Addition, subtraction, only like surds. Multiplication and division, anything. Like, unlike, everything can be multiplied or divided. Okay. Sixth one. Who can tell me the answer for the sixth one?
3 root 11, ma'am.
Square root 11, ma'am.
3 root 11.
3 root 11. Very good. Very good. 3 root 11 because it is 1 root 11 plus 1 root 11 plus 1 root 11. So 1 plus 1, 2, 2 plus 1, 3, 3 root 11 as it is. 3 root 11 as it is. Like x plus x is 3x. Very good. 7. Seventh one.
3 root 5 minus 4 root 3.
Ma'am, 3 root 5 minus 4 root 3, ma'am.
Correct. 3 root 5 because 1 root 5 plus 2 root 5 is 3 root 5. 3 root 5 minus 4 root 3. That's all. You cannot simplify this further. Because this is root 5, this is root 3. They are unlike surds. You cannot subtract them. You can multiply them, but you cannot subtract them. So this is the final answer. Very good. 8.
9 root 6 minus 7 root
That-
5.
9 root minus
Very good, Bhavishya. 9 root 6 minus 7 root 5. Because there's one root 6 here and root 6 here. 3 root 6 plus 6 root 6. 3 plus 6, 9. 9 root 6, not root 12. Root 6 plus root 6 is not root 12. Root 6 will come as it is. See, the reason is like this. 3 root 6 plus 6 root 6. So what is common? What is common? Root 6 is common. So in the bracket, you will get 3 plus 6. So 9 root 6. If somebody asks you like, why is it like that? Then you must tell them that, see, 3 root 6 plus 6 root 6, how to add? You'll have to take out root 6 common. Root 6 is common. So in the bracket, you will get 3 plus 6. So 3 plus 6 is 9. 9 root 6. 9 root 6. That's the reason. That is the reason. But you don't have to show these steps. You can directly write 9 root 6. 9 root 6 and minus 5 root 5 minus 2 root 5 is minus 7 root 5. Now this is root 6 root 5. So that's it. This is the final answer. Very good. 9th one.
Ma'am, 6 by 10 root 3.
6 by 10 root 3. Yeah, looks kind of correct. But 6 by 10 could be simplified further, right?
3 by 5 root 3, ma'am.
3 by 5 to the root power 5 by.
Not bad, yes. So see, children, this is like this. 9th one is 18 by 30 into, like how you put, when there are many, when you have like the square root of 2 into square root of 3, you write it as square root of 2 into 3. Similarly, square root of 5 by square root of 15 can be written as square root of 5 by 15. See, if it is square root of 5 into square root of 15, you can write it as square root of 5 into 15. In the same way, if the square root of 5 by square root of 15, you can write it as square root of 5 by 15. Is that fine, children?
Yes, ma'am.
Yes, ma'am.
Yeah, so you must write, divide 18 and 30. 18 by 30 into square root of 5 by 15. (18 by 30 into square root of 5 by 15. So 18 by 30 will be 6 3s are 18, 6 5s are 30. And here 1 and 3. So this is square root of 1 by 3. And square root of 1 by 3 is nothing but root 3. I'll tell you how. So it will be what? Next step is 3 by 5. 3 by 5 into square root of 1 by square root of 3. So square root of 1 is 1 only. What is square root of 1? 1. So 3 into 1 is 3 by 5 root 3. By 5 root 3. This is one way of working. This is 1 minute. I'll just do this again for you. Watch carefully. I'll do it in 2 ways. Just watch carefully. 9th one is 18 by 30 into square root of 5 by 15. This is the first step. 6 3s are 6 5s are. So you get 3 by 5. And here you get square root of 1 by 3. 1 by 3. So this is 3 by 5 into square root of 1 by square root of 3, which is square root of 1 is 1 itself. So 3 into 1 is 3. So 3 by 5 root 3. You can do it like this. Or the other way of doing it is, you can write 18 root 5, right? So 18 root 5 divided by 30 into, you can write the root 15 as root 5 into root 3. Because you know that, right? Root 5 into root 3 is root 15. Square root of 5 into square root of 3 is square root of 5 into 3, which is square root of 15. So you can split root 15 as square root of 5 into square root of 3. And you can simplify this. You can simplify this. You just cancel it out like this. So this is equal to, sorry, here also 6 3s are 6 5s are. So the result is 3 by 5 root 3. This is more simpler. You can just break down root 15 as root 5 into root 3. So 3 by 5 root 3. Is it understood, children? You can go with this always. Split root 15 as root 5 into root 3. Yes or no, children? Understood?
Yes, ma'am.
Yes, ma'am.
Next one. Next one, what's the answer? 1 by 3?
Yes, ma'am. 1 by 3.
Square root of 23 and square root of 23 gets cancelled. 16 by 48 is 1 by 3. 16 ones are 16 threes are 48. 1 by 3. Next one, 11th one.
2 root 30, ma'am. 2 root 30.
2 root 30. Okay. Because it is 2 into square root of 2 into 3 into 5. 2 into square root of 2 into 3 into 5. There's no, there's only 1, 2, 1, 3 and 1, 5. So nobody comes out of the square root. So it is 2 root 30. All of you tell me, children, any doubts, please ask me. Are you all getting the same answer?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. All right, children. The 12th one. Square root of 3 into square root of 3 into square root of 3 into square root of 3. Multiplication. So it
Three,
is
ma'am.
square root of 3 into 3 into 3 into 3. So now from 2 3s, 1 3 out of the square root. From 2 3s, 1 3 out of the square root. So 3 3s are 9. Am I right?
Yes, ma'am.
Yes, ma'am.
If you
Yes,
have gone
ma'am.
wrong, please take it down. See, there's a difference between, now what is root 3 plus root 3 plus root 3 plus root 3? This is different. Here, this is 1 root 3 plus 1 root 3 plus 1 root 3 plus 1 root 3. So here we take out root 3 common. Root 3 is common. So in the bracket, you get 1 plus 1 plus 1 plus 1. And the answer is 4 root 3. Root 3 plus root 3 plus root 3 plus root 3 is 4 root 3. Like x plus x plus x plus x is 4x. So do not get confused. When you're adding or subtracting, it's like taking out that root 3 common. And you will add or subtract only that numerical coefficient, that number. So for the 12th one, this is the answer. Square root of 3 into 3 into 3 into 3. 2 3s, 1 3 out, 2 3s, 1 3 out. So 3 3s are 9. 13, what's the answer for the 13th one?
Ma'am, I got 135 root 5.
135 root 5. Okay. 13th one. Okay. 135 root 5. Ah. Yes, class.
Ma'am, 5.
Who's that 5? Who said 5? Why, what happened? Who said 5?
Sahana, ma'am.
Yeah, that's right. 5 is the correct answer. So cube root of 5 into cube root of 5 into cube root of 5 is cube root of 5 into 5 into 5. So under the cube root, when you have 3 equal factors, 1 comes out. So the answer is 5. Well tried, Sahana. But whereas cube root of 5 plus cube root of 5 plus cube root of 5. This is different. This is like you're taking out cube root of 5 common. So in the bracket, you'll get 1 plus 1 plus 1 because there's 1 here, no? 1 plus 1 plus 1. So it is 3 cube root of 5. Addition is 3 cube root of 5. Addition is 3 cube root of 5. But when you're multiplying, it's cube root of 5 into 5 into 5. So 3 5s, 1 5 out of the cube root.
Why don't we take 3 from all the 5s and then multiply them? And then
Tell me
take
what
5.
you have written. Then I can help you. Tell me what you have written. I'll tell you.
I have multiplied 3 times, and then I have took 5 from all the 3 5s.
No. What 3 times? You read what you have written in your book. Then only I can understand. Read what you have written.
3 into 3 into 3, and
Where
root
is 3? Where is 3?
Like the root of 5.
Cube root of 5. From cube root of 5, you cannot take the 3 out. Okay. Fine. Okay. Now I'll come to that also. Now, where is 3? See, okay. I think, Swati, there is a difference between 3 root 5 and cube root of 5, Swati. I think you're confused between these two. 3 root 5 is 3 into root 5. This is cube root of 5. I don't know if you're confused between these two. 3 root 5 is 3 into root 5. But this one is cube root of 5. They're totally different. Yeah, now read your answer, Swati.
The one that I've written before you discussed the answer.
No, that is, like the clarification to your incorrect answer. Read out your steps.
3 into 3 into 3. And root. Inside the root, we have 3 5s. 5 into 5 into 5.
That is what you have interpreted. You have interpreted cube root of 5 as 3 root 5, which is incorrect. See, I'll tell you. The value of root 5 is approximately 2.224. Okay, so like 3 into 2.2. Let me take. This is cube root of 5. So this one is approximately like 6 point something. Cube root of 5, is what? Some value which when multiplied by itself 3 times should give you 5. So 1 into 1 into 1 is 1. 2 into 2 into 2 is 8. So the value of cube root of 5 will be less than 2. Because 2 into 2 into 2, 2 cubed is 8. Now this is 5. So it will be less than 2. This value will be less than 2. But 3 root 5 is 6 point something. They are two different things. Swati, are you out of that? You still have the same feeling?
No, ma'am.
Okay. Next one. The 14th one. What's the answer for the 14th one?
Ma'am, 4 into 5. 4 into 3.
Cube root of 5. 4 into cube root of 5. When it's addition, it's like you're taking cube root of 5 common. So it will be 1 plus 1 plus 1 plus 1, which is 4 cube root of 5. You should put the 3. See, it's not 4, 3 like this. It's not like this. You must properly write. You must properly write cube root of 5. You must properly write that 4 into, see here. Here it should be 3 of 5. Put the V wider so that you can put the 3 inside. Don't write like this and put 3 here. It should look like, give that space for 3 or whatever number to be written, give that space. So 4. Okay. Yeah, the last one, 15th one.
Ma'am, 2 into 4th root of 2 plus
4th root of 2 plus square root of 4 minus 6 4th root of 5.
Anirudh, once again. Tell again, Anirudh.
Fourth root of 2 plus root 4 minus 6 fourth root of 5, ma'am.
I understood this minus 6 fourth root of 5. I understood. But what did you say before that? I don't get that.
4 square 4 roots 2 plus
4 root 2.
root
No.
4.
That's how 4 root 2. No. Only
2 fourth
everything
root of 2.
Yeah. It's 2 fourth root of 2. Because there's 1 here and there's 1 here. 1 plus 1 is 2. 2 fourth root of 2. 2 fourth, 1 plus 1, 2. 2 into fourth root of 2 minus 6 into fourth root of 5.
Okay, ma'am. I understood.
Okay, very good. See here, it's like this. So the 15th one is fourth root of 2 plus fourth root of 2 plus fourth root of 5 minus okay, so minus 7 fourth root of 5. So here you need to simplify these two and these two. So fourth root of 2, fourth root of 2. So fourth root of 2 is like common. 1 plus 1. 1 plus 1 is 2. 2 fourth root of 2. Now simplify these two. So this is like plus 1 minus 7 minus 6. Minus 6 fourth root of 5. All right, children?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Okay. Now, from this, you should have realized that root 7 into root 7 is 7. Because root 7 into root 7 is root of 7 into 7. And from 2 sevens, 1 7 comes out. So root 7 into root 7 is 7. Root 5 into root 5 is root of 5 into 5. And from 2 5s, 1 5 will come out. So 5. So that means root 3 into root 3 is 3. Root 11 into root 11 is 11. Because it is root of 11 into 11. And from 2 11s, 1 11 out. But root 11 plus root 11 is 1 root 11 plus 1 root 11, which is 2 root 11. Now, if it is a cube root of 5 into cube root of 5 into cube root of 5. So this will be cube root of 5 into 5 into 5. Because everywhere it is cube root. So you can write the cube root once and put all the numbers under the cube root. 5, 5, 5, 5 into 5 into 5. So from 3 5s, 1 5 will come out of the cube root. So the answer is 5. But if it is cube root of 5 plus cube root of 5 plus cube root of 5, then it is 1 plus 1 plus 1, 3. 3 into cube root of 5. 3 into cube root of 5. But we'll mostly come across this situation like a root, like 7 into root 7 is 7. Because root of 7 into 7 from 2 sevens, 1 7 will come out. So root 7 into root 7 is 7. Root 2 into root 2 is 2. Root 3 into root 3 is 3. Now we'll understand this in a different way also. I'll tell you how to, there are two things called the radical form and exponential form. Exponential form. See, from 8th to 9th is a big change, you know, so you'll come across many new things. So that's not equal to not understanding. When I'm saying something, if you're following, that means you are clear with it. But then at the end of the session, if you sit and think, you know, what all I learned today, it may be difficult for you to recall. That's because you're learning many new things. And it's so different from what you learned in 8th standard. So without the notes with you, no, it will be difficult. So please bear with me. Tomorrow when I send the notes and you write down everything in your classwork, then you have the notes in your book to go through. Then things will really become clear. That will be followed by an assignment. So then things will be really clear. Please bear with me till then. So now this is another new thing, radical form, exponential form. Now, when we write square root of 2 like this is said to be in the radical form. The exponential form will be, write this 2 as it is. And square root means there is a 2 here, but we don't write it. Like, you know, when we write 5, it is plus 5, but we don't write plus 5. When you write 5, it is plus 5 only. Similarly, when you write like this, there is a 2 here, but we don't write the 2. There is 2 there. That's why we say square root of. And when we put a 3 there, we say cube root of 5. When we put a 4 there, we say 4th root of 7. When we put a 7 there, we put say 7th root of 10. That's why it is square root of, because there's a 2 there. But we don't write the 2. But there is a 2 there. You can write if you want. If you want, you can write it. Even if you don't write it, it is square root. But for cube root and other things, you should show that number. Now, this is the radical form. For the exponential form, write this radical as it is. This is called the radicand actually. This is called the radicand. Write this one as it is. Write this as it is. Now this one, there's a 2 here, no? Write it as its reciprocal. As its reciprocal. So 1 by 2. 1 by 2. So now see here. Supposing it is 5 and 4 here. Write this. This is 4th root of 5. How do we read this? 4th root of 5. Now, how do you write it in the exponential form? Write this 5 as it is, the radicand as it is, and this 4 will become its reciprocal, 1 by 4. Now, supposing you have, say, the 11th root of 2 to the power, okay, not, okay, for example, 2 to the power, something like 7. Okay, so write the 2 to the power 7 as it is. Write 2 to the power 7 as it is. Now 11 will become its reciprocal, right? So 1 by 11. So into 1 by 11, into 1 by 11, because there's already a power, no? There's already a power 7. Now you need to write 1 by 11. What is the connect? Meaning, how will you connect 7 and 11? 7 and 1 by 11 with a product sign. 7 into 1 by 11. So this is nothing but 2, 7 by 11. 2 to the power 7 by 11. 2 to the power 7 by 11. Now tell me for this, children. What will this be?
X to the power y into 1 by 3.
No, that's Z. That is Z. Z. So it will be X to the power
Y by Z.
Y by Z. Y by Z. X to the power Y by Z. X to the power Y by Z. So this radicand, you should write it as it is. This radicand, write it as it is. This one, write it as it is. And take the reciprocal. So here it will be 1 by 2, 1 by 4, 1 by 11, 1 by Z. There's already a power. So into 1 by Z. Y into 1 by Z is Y by Z. So X to the power Y by Z. Now, when we write square root of 3 into square root of 3, this is nothing but 3 to the power 3 to the power
1/2.
1/2 into 3 to the power
3 to the power 1/2.
1/2. So now what have you learned in exponents? When bases are same and it's multiplication, we add the powers. So 1/2 plus 1/2. What is 1/2 plus 1/2? 1. So 3. That's what it is. That's what we get like this also. Square root of 3 into square root of 3 is square root of 3 into 3. Some from 2 3s, 1 3 out. Here we are converting it to the exponential form. Square root of 3 is nothing but 3 to the power 1/2. Again, this one is also 3 to the power 1/2. It's multiplied. So when bases are same and it's multiplication, we add the powers. 1/2 plus 1/2. Half plus half is 1, which is 3. The same you get like this also. Tell me this in the exponential form.
Ma'am, 7 into 1/7. 7 to
Not
the 1/7, ma'am.
7 to the power. 7 raised to the power 1/7. 7 raised to the power 1/7. Now tell me this one. Okay, I'll tell you this. Okay, so you must first write this one as 2 to the power 4 into 1/3. First write 4/3 as 4 into 1/3. Okay, write 4/3 as 4 into 1/3. Now 1/3. So it will be cube root. And write this 2 to the power 4 as the radicand. Now supposing 3 to the power 7/5. This should be written as 3 to the power 7 into 1/5. So now this 1/5 meaning fifth root. 3 to the power 7 will be the radicand. 3 to the power 7. Okay, so I'll share all this with you tomorrow. When you write down, it will be more clear. Now so this is about exponential form and radical form. Now let's recall the identities, the algebraic identities we learned in 8th standard. We know that a square plus 2ab plus b square is equal to what, children? Is equal to
A plus
A plus B the whole square.
a plus b the whole square. What is a square minus 2ab plus b square?
A
A
minus
minus
B.
A minus b the whole square. Very good. What is a minus b into a plus b?
Ma'am, A square minus B.
A square minus B square.
A square minus b square. A square minus b square. How will you multiply? Supposing you have x plus y into a plus b. How will you multiply this?
Ma'am, X into A plus B plus Y into A plus B.
Very good. X into a plus b plus y into a plus b. You should simplify this further, but I just wanted the first step. If it is x plus y into a plus b, how do you multiply? X into the second bracket plus y into the second bracket. X into a plus b plus y into a plus b. All right. Now, let's see how to simplify. simplify using algebraic identities. All right. So if you have 2 root 3 minus root 5 into 2 root 3 minus root 5. Listen very carefully, children. Any questions you can ask me? See here. Now, supposing you'll have to multiply these two using an algebraic identity. So 2 root 3 minus root 5 into 2 root 3 minus root 5. You're multiplying the same thing 2 times. Or it's like a into a minus b into a minus b. Correct? A minus b into a minus b. Yes or no, children? 2 root 3, 2 root 3, root 5, minus, minus. So it's like a minus b into a minus b. Yes or no?
Yes, ma'am.
Yes, ma'am.
So you can write it as what? You can write it as?
A minus B the whole square.
A minus
Yeah, a
5
minus b the whole square. A minus b the whole square. A minus b into a minus b is a minus b the whole square. Now, how do you expand this using the identity? A square minus 2 into a into b plus b square. Now, what is a here? A, this is a square minus 2 into a into b plus b square plus b square. Now, what is 2 root 3 the whole square? 2 root 3 the whole square means 2 root 3 into 2 root 3. Now, 2 2s are 4. Root 3 into root 3 is 3. Root 3 into root 3 is 3. 4 3s are 12. 2 root 3 the whole square means 2 root 3 into 2 root 3. 2 into 2, 4. Root 3 into root 3, 3. 4 3s are 12. Minus 2 into 2, 4. Root 3 into root 5 is root of 3 into 5. So 4 root 15. Because 2 2s are 4 into root of 3 into 5. So 4 root 15. Yes or no?
Yes, ma'am.
Yes, ma'am.
Plus root 5 into root 5 is 5. Root 5 the whole square means root 5 into root 5. Root 5 into root 5 is 5. Next step, 12 plus 5, 17 minus 4 root 15. That's all. This cannot be simplified further. Now don't write 7 minus 4 is 13, so 13 root 15. This is wrong because they're not like, they're unlike. This is third. This is just a number, meaning it's a natural number. This is third. This is rational. This is irrational. This one is rational. This is irrational. You cannot simplify them further. You can multiply them. 7 into 4 root 15. 17 into 4 root 15. 17 into 4, 68. 68 root 15. You can multiply them. You cannot add or subtract them. This is the final answer. Isn't it simple, children? Difficult, is it?
No, ma'am.
Now I'm going to give you a test now. That's why I'm asking you. Any doubts here? So how do you
No
start
doubts,
this?
ma'am.
Okay.
No
So
doubt.
it's like a minus b into a minus b. So how do you multiply a minus b into a minus b is a minus b the whole square. Now what is a minus b the whole square? A square minus 2ab plus b square. Then you'll have to simplify. And then 12 plus 5 is 17. And that's it. Now supposing it was, oh, I shouldn't have removed this. Okay. Supposing it was 2 root 3 plus root 5. Plus and plus here. Then it will be 2 root 3 plus root 5 the whole square. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now tell me what will it be? A square plus 2 into a into b plus b square. So what should I write here?
2 root 3.
Ma'am, 2 root 3.
2 root 3. Here
Root 5.
Root 5. Here?
2 root 3 into root 5.
Yeah, 2a into b. Okay, now what is 2 root 3 into 2 root 3? 2 2s are 4. Root 3 into root 3 is 3, so 12. 12. Plus 2 2s are 4. Root 3 into root 5 is root 15. So 4 root 15. It's not root 60, children. Don't multiply 4 and root 15. It's not root of 15 into 4 root 60. How can 4 get into the square root? It's not root 4. It's only 4. So you cannot put this 4 under the square root. Plus 5. Because root 5 into root 5 is 5. Now 12 plus 5 is 17. Correct?
Yes, ma'am.
Plus 4 root 15. Plus 4 root 15. Now the other one is, what if it is a plus b into a minus b? Now so far we saw a minus b into a minus b, a plus b into a plus b. So a minus b into a minus b is a minus b the whole square. A plus b into a plus b is a plus b the whole square. Then what is a plus b into a minus b? A plus b into a minus b. So this is like a plus b. See here, 2 root 3 plus root 5, 2 root 3 minus root 5. A plus b into a minus b. 2 root 3 plus root 5, 2 root 3 minus root 5. A plus b into a minus b. So the answer is a square minus b square. A square minus b square. See, the given expression is of the form a plus b into a minus b, where a is 2 root 3 and b is root 5. So the question is like a plus b into a minus b. So the answer is a square minus b square. This is only the answer. A square minus b square. So a square means 2 root 3 the whole square. B square means root 5 the whole square. So this one will be 2 root 3 into 2 root 3 into 2 root 3. 12 minus 5. So the answer is 7. That's all. The 7 is the answer. I'll give another example for this one. I'll give another example for this. Supposing you have 3 root 7 plus 4 into 3 root 7 minus 4. So again, this is like a plus b into a minus b. Okay, so the answer is a square minus b square. So because it's like a plus b into a minus b, the answer is a square minus b square, wherein your a is 3 root 7 and b is 4. So the answer is a square minus b square. So put 3 root 7 here and 4 here. 3 root 7 the whole square means 3 root 7 into 3 root 7. 3 into 3 is 9. Root 7 into root 7 is 7. And 7 nines are 63. 63 minus 4 fours are 16. When you subtract 13 minus 6 is 7, 47. Is this understood, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right. Now get ready for the test. Do it in your rough notebook. Yeah, start working this. Don't wait for the other questions. Take this question and start working this. Okay, children, please work. I'll just come back in 2-3 minutes. We'll discuss one or two. We won't wait for all the 6 to be completed. I'll just come back in 2 minutes. Maybe you would have finished the first and second one. We'll discuss this, and then we'll go to the third and fourth. Okay, please stop writing. You should have finished at least 2 by now. If you have done 3, good. At least 3 you should have finished. Let's see the answer for the first one. Who wants to say the answer for the first one?
Ma'am, may I?
Yes.
Ma'am, 124 plus 70.
124 plus
70
uh,
root 3, ma'am.
70 root 3, is it?
Yes, ma'am.
Okay. Children, what I'm working it, see here. So it's nothing but 5 root 3 plus 7 the whole square. So it is a square. That is 5 root 3 the whole square plus 2 into a into b. 2 into 5 root 3 into 7 plus 7 the whole square. So 5 root 3 into 5 root 3, 25 into 3, 25 into 3, 75 plus 2 5s are 10, 10 7s are 70. So 70 root 3 plus 7 square is 49. So this, when you add 75 and 49, when you add, you will get 124 plus 70 root 3. Correct. Bhavishya, you're right.
Okay, ma'am.
How many of you got this answer? Raise your hand. How many of you got this answer? Swati, Sahana, Mritsa, Laksha, Aniruddhan, Abhishek, Aragamai. You two got it. Very good. Okay. All of us in the class today have got it right. Very good. That's great. Sadhana and Sabarna, are you there in the meeting? Sadhana and Sabarna, or you were not in the meeting for some time?
Ma'am, I got poor network connection, and so I was not in the meeting for some time.
Yeah. That's what I couldn't see you earlier. Okay. No worries. I'll share the recording. You can watch it later. Okay.
Okay.
Yeah. Yeah. Somebody else tell me the answer for the second one.
Can I?
Yeah, Swati.
Ma'am, I got 621 minus
621 minus 88. Ma'am,
621 minus
88 root 5.
88.
Okay, let's check that. This is the answer for the first one. I'm doing the second one here. The answer for the second one here. So it is 11 root 5 minus 4 the whole square. The whole square. Because 11 root 5 minus 4 into 11 root 5 minus 4. So 11 root 5 minus 4 the whole square. So now this is a minus b the whole square. So a square, 11 root 5 the whole square, minus 2 into a into b, 2 into 11 root 5 into 4, plus b square, plus 4 square. So 11 root 5 into 11 root 5, 121 into 5, because 11 into 11 is 121, root 5, 121, root 5 into root 5 is 5, and 125 into 5, 0, 1 carried over, 605. 605 minus 11 into 8, 88 root 5 plus 16. So it's right. 620, that is nothing but 621, because 605 plus 16 is 621 minus 88 root 5. This is correct. Very good. Yeah, do the third one, children. Have you all finished the third one?
Yes, ma'am.
Yes,
Completed, ma'am.
Yes, ma'am.
ma'am, yes, ma'am. Aniruddhan.
Oh, very good, very good. 3 root 2, 4 root 3. Okay. Aniruddhan, read your answer for the third one.
66 plus 24 square 6.
Root 6. Okay. Yeah, tell me the first step. It is what? It's what the whole square?
What, ma'am?
No, read out your steps.
Okay. X plus y square whole x plus y whole square. X is equal to x square. What? 3. Y is equal to
Okay, I don't know why it's not clear.
is equal to 3 root 2 square.
3 root 2 I heard. What is it here? What is it here, Aniruddhan?
Ma'am, 3 root 2 whole square plus 3 into 2 into 3 into 4.
No, now only your voice is
4
clear. 1 minute. 3 root 2
2
the
into
whole
root
square.
3
3 root 2 the whole square plus 2 into
plus
2 in 3 root 2 into
4
no, it's not clear your voice. I can't hear anything.
root 2 into root 3.
No. 3 root 2 the whole square plus 2 into 3 root 2 into
3 root 2 into root 3.
no, I don't know. I don't have the question also. You should only tell me. I don't know. Okay, children, what is it? 3 root 2 the whole square plus 2 into 3 root 2 into
4 root 3, ma'am.
4 root 3 plus 4 root 3 the whole square. Okay. What is this, Aniruddhan? What is?
Ma'am, Aniruddhan.
Yeah, what is 3 root 2 the whole square? Yeah.
I splitted the
I'm sorry, Aniruddhan. You want to say, but I'm not
and
able
4
to hear
root
you.
3, ma'am.
No, I can't hear you, darling. I can't hear you. What is 3 root 2 the whole square, children?
Ma'am, 18.
18. Plus, here this one.
24
root 6.
24 root 6.
Then plus
48.
48.
48. Very good. 48. Now 18 plus 48. Now how do you get root 6? Because 2 3s are 6, 6 4s are 24. And root 2 into root 3 is root of 2 into 3. You can multiply anything. So root of 2 into 3, so root 6, 24 root 6 plus 48. So 18 plus 48 is 64 plus 24 root 6, correct? Aniruddhan, you got this? 64 plus 24 root 6?
I'm 66, mom.
I'm 66.
Oh, 66, sorry, 66. 66. All of you got this?
Yes, ma'am.
Yes, mom.
Yes, ma'am.
Very good. Okay, continue, children. Please continue.
Completed, ma'am.
Completed,
Done,
ma'am.
Okay, I'll just wait for some time. Maybe there is somebody who's not finished.
Ma'am, I'm having doubt in 6th sum, ma'am.
Yeah, sure. We'll do it. Yeah. Yeah, complete the fourth one, children, for me. What is 7 root 5 the whole square?
245.
45, ma'am.
Yeah. So 7 root 5.
245, ma'am.
Yeah, 7 root 5 into 7 root 5. 7 sevens are 49. Root 5 into root 5 is 5. So 49 into 5, 245. Minus, what is this?
42 root 5.
42 root 35.
45 root of 35. Because 5 sevens are 35 under the square root.
42, ma'am.
42, yeah. 42 root of 35, correct?
Yes, ma'am.
63.
63, okay. 7 nines are 63, very good, yes. So what is 245 plus 63?
308.
308
minus 42 root 35.
Very good, all of you. Most of you have got it right. Some of us are not answering, so I don't know. I hope you've all got it right. Okay. So fifth one is what? A minus B into A plus B. So what is it?
Ma'am, 6 root 2 the whole square. Minus 3 root 5 the whole square, ma'am.
Yeah. So it's A minus B into A plus B, which is A square minus B square. A square minus B square, because it is A minus B into A plus B. See, a 6 root 2, 6 root 2. 3 root 5, 3 root 5. So A, and then the connector is minus plus. So A minus B into A plus B. A minus B into A plus B is A square minus B square. What is 6 root 2?
72 minus 45,
72
ma'am.
minus 45.
Minus 45 is equal to 27.
Very good. All of you check your answers till here. I'll do the sixth one. I have to clear the screen and then do the sixth one. I'll just give a minute. Okay. So somebody tell, maybe I'll do it on the next slide. What is it? 3 root 2 plus 5. 3 root 2 plus 5 into 2 root 3 minus 9. 2 root 3 minus 9. Yes. Now, this does not fall under any identity. This one, this expression or this question does not fall under any identity. Then do the regular multiplication. What is it, regular multiplication? Multiply the first term with the second bracket, and multiply the second term with the second bracket. That is the first term of the first bracket with the second bracket, the second term of the first bracket with the second bracket. Then after this, multiply these two terms. 3 into 2, 6. Root 2 into root 3, root 6. Then multiply these two terms. 3 root 2 into minus 9, minus 27 root 2. Then multiply these two. 5 2s are 10, 10 root 3. And finally, these two. Plus 5 into minus 9, minus 45. Now this cannot be simplified further. So this is the final answer. This is the final answer. So I'll work it again for you. 3 root 2 plus 5 into 2 root 3 minus 9. Does not this product, to find this product, you cannot use any identity. So then how do we multiply? Write this first term, 3 root 2. Multiply that with the second bracket, 2 root 3 minus 9. Write the second term with the sign, plus 5 or minus 5, whatever is the sign. Multiply it with the second bracket, 2 root 3 minus 9. This is the first step. This is the first step. Now, what do you do? What do you do? Multiply 3 root 2 and 2 root 3. So 6 root 6. Next, multiply these two. So 3 root 2 into minus 9, minus 27 root 2. Now multiply these two, plus 10 root 3. And finally, these two, plus 5 into minus 9, which is minus 45. All are unlike. This is root 6, root 2, root 3, and 45, all unlike terms. So that's the final answer. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Very nice. Okay. So like how we add, subtract, multiply, and divide algebraic terms for algebraic expressions, we have understood how to add, subtract, multiply, divide irrationals. Irrationals. Okay. Now, consider this decimal 125.125. How do you put it in the P by Q form? How do you put it in the P by Q form? This is nothing but 125. 125. Remove the decimal point, divided by 1000. Is this correct, children?
Yes, ma'am.
Yeah. Now simplify. Simplify. Divide this. Simplify this and tell me the simplest form of this fraction. I want the simplest form of this fraction.
11 by 40.
11 by
40, ma'am.
Sahana, is it?
Yes, ma'am.
Okay. Let me see what your friends have to say.
1 by 8, ma'am.
Okay, Sahana says 11 by 40. Oh, yeah, there's somebody else. 1 by 8, huh?
Yes,
Who said that? 1 by 8?
Sadhana, ma'am.
Sadhana. Okay, Sadhana says 1 by 8. Okay.
Can I?
Yeah, please tell me. Yes.
Oh my God. 1001 by 8.
Swati says 1001 by 8. Yes, others? Okay, fine. Now let's divide. Now the numerator and the denominator is divisible by 125. So I'm going to divide 125, 125. That is 1,25,125 divided by 125. 125 ones are 125. 0 is the remainder. 1 comes down. It's not possible to divide. So add a 0 and bring the next digit down. 2 comes down. Again, it's not possible to divide. So add another 0 and bring the next digit down. Now 125 ones are 125 and the remainder is 0. So the numerator simplifies to 1001 by the denominator. When you divide 1000 by 125, you get 125 8 times is 1000. So the simplest form is 1001 by 8. And it's easy to understand because when the denominator is 40, when 1000 is 40, 1,25,125 cannot be 11. So it's very easy to make out. See, the numerator is bigger than the denominator. So after simplifying also, the numerator should be greater than the denominator. Okay, you can see the numerator is bigger than the denominator. So after simplifying also, the numerator will be greater. So we cannot get 11 by 40. So similarly, 1 by 8 also is not possible. You can make what I'm saying. See, we may go wrong, but when we get the answer, you should be able to judge that, no, this is not possible. That means you've gone wrong somewhere. So the correct answer is 1001 by 8. Okay, I'm sure all of you understood because I've also shown the division alongside.
Ma'am, is it also okay to divide this rational
by 5
number
3
by
times.
5?
5
Yes,
3
ma'am.
times. Yeah. You can divide by 5 3 times. 5 5 5 3 times. When you divide by 5, you will get the same thing. 1001 by 8. Now this is a terminating decimal. This one is a terminating decimal because 125.125. It's a terminating decimal. Now consider this 125.125 recurring. 125.125 recurring. Now this cannot be written as this is not equal to this. It's not equal to this. But we know that a non-terminating repeating decimal has a P by Q form. This is a non-terminating repeating decimal. And we know that a non-terminating repeating decimal also has a P by Q form. There are two decimals. There are two kinds of decimals that have a P by Q form. A terminating decimal. A terminating decimal has a P by Q form. A non-terminating repeating decimal also has a P by Q form. Now, this one is a non-terminating repeating decimal. 125.125, 125, 125. It's a repeating decimal. This one also has a P by Q form. Now, the question is how to find the P by Q form. P by Q form of a non-terminating repeating decimal. That's what we're going to understand now. 125.125 recurring. So we start like this. Don't write, listen to me. Let x equal to 125.125 reckoning. So that means what is x? X is equal to 125.125, 125, 125. It goes on like this. Now, how many digits are in the repeating block? That is the next question. How many digits are there in the repeating block? The repeating block has 3 digits. 3 digits. The repeating block has 3 digits, 1, 2, and 5. The repeating block has 3 digits, 1, 2, and 5. So you should multiply x with 1000. 3 digits means like 3 zeros, 1000. If the repeating block has 2 digits, then multiply by 100. Multiply x by 100. If the repeating block has 4 digits, then multiply x by 1000, and so on. Now the repeating block has 3 digits. 125, 125, 125, 3 digits. So you should you can call this equation 1. Next, you must multiply x with 1000. Why 1000? Because 125, 3 zeros. So 1000, 1 followed by 3 zeros. So 1000x is equal to, that is, you're multiplying x by 1000. See, like if you have x is equal to 5. Okay, what is 10x equal to? 10x will be equal to 5 into 10, 50. What is 100x equal to? 100x will be equal to 5 into 100, 500. If you're multiplying x by 100, you should multiply 5 also by 100. If you're multiplying x by 10, multiply 5 by 10. So here you're multiplying x by 1000. So multiply this one by 1000. That is this one by 1000. So when you multiply this by 1000, what will happen? This decimal point will get shifted. 1, 2, 3. It will move here. Yes or no?
Yes, ma'am.
Yes.
Okay. When you multiply x by 1000, the decimal point will get shifted to the right by 3 decimal places. So see here, when you multiply x by 1000, the decimal point which is here will move by 3 places. 1, 2, 3. It will come here. So 1000x will be equal to 1000x is equal to 125 point, then 125. That this one goes on. This one goes on. You can write how many ever times you want. It's not that if the decimal point comes here, there is only 2 set. There's only 2 set here. So why you have written 3 times? See, there are infinitely many 125s. There are infinitely many 125s. Okay. So what I am doing is, I'm going to write the same number of sets after the decimal point. I'm going to write the same number of sets after the decimal point. Okay, so here there is 1, 2, 3 after the decimal point. So I've written 1, 2, 3 here also after the decimal point. Now you will ask me, no, but when you shifted the decimal point 1, 2, 3, the decimal point comes here. Then there are only 2 sets. Children, there are many sets. 125, 125, 125. There are so many. So it's not only 2 or 3. Remember that. Okay, I hope you all understood that. Oh. So you multiply by 1000 and you get 1000x. All right. Now this is equation 2. Now you need to perform equation 2 minus equation 1. This is what you need to perform. Equation 2 minus equation 1. What is equation 2? 1000x is equal to 125, 125. That is 1,25,125. 125, 125, 125 goes on forever. Goes on forever. Okay. Minus x. What is x? X is 125 point 125.125, 125 goes on forever. Goes on forever. Now I said you should subtract these 2 equations. Subtract these 2 equations. So now 1000x minus x is 999x is equal to. Now you see here after the decimal point, you have the same thing after the decimal point. After the decimal point, you have the same thing. So they get cancelled. You have the same thing after the decimal point in both the cases. So they get cancelled. Now this one, 125 minus 125 is 0,00521. 1,25,000. 1 lakh. You don't have to put the comma. Actually, you don't have to put the commas. So when you subtract, you get 125,000, 3 zeros. So x is equal to 125 followed by 3 zeros divided by 999. Now you see, now you can use the test of divisibility. 5 plus 2, 7, 7 plus 1, 8. So the numerator is not divisible by 3. The numerator is not divisible by 3. The denominator is divisible by 3. The numerator is not divisible by 3. The numerator is divisible by 2, but the denominator is not divisible by 2. So you need to check if this is the simplest form, and it looks like this is the simplest form. So now the P by Q form of 125.125 recurring is 1,25,000 divided by 999. If you use your calculator, see here, I have the calculator with me. I'm going to feed this information. I'm going to say 125 3 zeros divided by 999 and see what my calculator says. I don't know if all of you can see it, but I'm trying to show it. I don't know if it is visible. Is it visible? No, right? Okay, let me not try it and waste time. You can check it. No problem. You can check it with your calculator. You can check it with your calculator. Children, I think I was not audible for some time, right?
Yes, ma'am.
Yeah,
Yes, ma'am.
yeah. I'll just repeat what I was telling you. Just a second. I'll share my screen. Yeah, I've shared my screen. Is it visible, children?
Yes, ma'am.
Yes, ma'am.
Yeah. Okay. I'm just going to repeat the same thing so that it's very clear. I'm doing the same thing again. Okay. 125.125. This is a terminating decimal. It's a terminating decimal. Terminating decimal. Its P by Q form is 125.125 is equal to 125 divided by, because after the decimal point there are 3 digits, divided by 1000. Divided by 1000. So on simplifying, we got 1001 by 8. This is the P by Q form for 125.125, which is a terminating decimal. Now we were talking about the P by Q form of the non-terminating repeating decimal 125.125 recurring. This one is a non-terminating repeating decimal. What is the P by Q form of this one? What is the P by Q form of this one? This also has a P by Q form. Because it's a non-terminating repeating decimal, it has a P by Q form. How to find its P by Q form? That's what we were discussing. Am I audible, children? Is my screen visible?
Yes, ma'am.
Okay.
Yes, ma'am.
So for that, very good. Thank you. So for that, x is equal to 125.125 recurring. This is the first step. Next step, x is equal to, so we say let, okay? X is equal to 125 point. What is 125 recurring? 125, 125, 125 goes on forever. And we call this equation 1. Next, we'll have to construct equation 2. How? By multiplying equation 1 by a suitable number like 10, 100, 1000, 10,000, so on. Now, how to decide by what to multiply? How many digits? See here, in the repeating block, we have 3 digits. 1, 2, 5. 3 digits are there in the repeating block. So 3 digits meaning put 3 zeros and 1,000. So multiply x, this equation x by 1000. So x into 1000 is 1000x is equal to, when you multiply this one by 1000, this decimal point will shift by 3 places. 1, 2, 3. It will come here. It will come here. So it will be 1000x will be equal to 125, 125.125, 125. How many ever times you want, you can write this, because there are infinitely many. Call this equation 2. After multiplying it by 1000, call that equation 2. Now you must perform equation 2 minus equation 1. This is what you should do. 2 minus 1 you should do. So write 2 first. 1000x is equal to 125, 125.125, 125, 125 goes on forever. X is equal to, because that's equation 1. Write 125 here. Write it correctly. 0.125, 125, 125 goes on forever. Goes on forever. You need to subtract, not add, subtract. 1000x minus x, 999x is equal to, the decimal parts gets cancelled in both. Now, when you find the difference, you get 125,000. So 999x is equal to 1,25,000. X is equal to 1,25,000 divided by 999. This is the P by Q form for 125.125 recurring. Is that understood, children?
Yes, ma'am.
Yes, ma'am.
Yeah. Now, okay, good. Now, supposing you want to write 18.48 in the P by Q form. So then you should say x is equal to 18.484848 goes on forever. This is equation 1. Then you must find 100x. Why? Because the repeating block has 2 digits, 4, 8. The repeating block has only 2 digits, 4 and 8. So 2 digits means 2 zeros. So 100x. So multiply x with 100. So 100x is equal to, when you multiply this one by 100, this decimal point will move by 2 places. 1, 2, it will come here. So it will be 1848.484848. You can write how many ever times you want. This is equation 2. This is equation 2. Next, you need to perform equation 2 minus equation 1. So write equation 2, 100x is equal to 484848 goes on forever. X is equal to 18.48 48, 48, 48. So I always write it 3 times after the decimal point. That repeating block, you know, you can write it even 2 times. I normally write it 3 times. Goes on forever. You need to subtract. So subtract 100x. This is not 1000. 100x minus x is 99x, not 999. 99x. Okay, and here when you subtract this, the decimal parts they get cancelled, and when you subtract, you get 1830. So x is equal to 1830 divided by 99. You should always put it in the simplest form. You can divide this by 3 further because use a test of divisibility. 8 plus 1, 9, 9 plus 3, 12. Yeah, it is divisible by 3. So that is your job. To put it in the simplest form is your job. Understood this, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now, supposing you have, very good. Supposing you have 123.7 recurring, then you should multiply by 10x. Because 7, only one digit is recurring. 7, 7, 7, 7, 7 goes on forever. Only one digit is recurring. So one digit meaning only 1 0, that is 10x. So you should write x and then you should find 10x. And you should subtract 10x minus x. So you'll get 9x is equal to. So 10x minus x means you'll get 9x. 100x minus x is 99x. 1000x minus x is 999x. That's all. The procedure is the same. If one digit repeats, 10x. 2 digits, 100x. 3 digits, 1000x. 4 digits, 10,000x and so on. And you should always subtract, right? That equation first, that 10x, 100x, that equation first. Then that x equation, you should subtract. Subtract, and that's the P by Q form. Understood, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Sure, children, all of you?
Yes, ma'am.
Yes,
Okay,
ma'am.
Yes, ma'am.
all right. Just 2 more minutes, children, once. Now, tell me is, say like 4th root of 16. What's the value of 4th root of 16? It's a 4th root of 2 into 2 into 2 into 2, right? So from
Yes,
4
ma'am.
2s, 1 2 will come out. So the value of 4th root of 16 is 2, and 2 is 2 by 1, which is P by Q. So 4th root of 16 is a rational number. It's a rational number. Whenever you have to comment if an expression is rational or irrational, you must simplify if possible, and then we must decide. We should not decide before simplifying. Just because you see it as 4th root of 16, this is irrational. It's not like that. You can simplify this 4th root of 16. That is 4th root of, when you find the factors of 16, 2 8s, 2 4s, 2 2s, 2 1s. So 16 can be written as 2 into 2 into 2 into 2. So from 4 2s, 1 2 will come out because 4th root, no? So from 4 2s, 1 2 out. And what is 2? 2 means 2 by 1. Integer by integer. It's a rational number. Therefore, 4th root of 16 is rational. It's rational. Now, supposing, say like square root of 30. Okay, square root of 30. Now, 30 is what? 30 is 2 15 times 3 5s, 5 1s. So this is square root of 2 into 3 into 5. Now there's only 1 2, 1 3 and 1 5. So nobody can come out of the square root. So square root of 30 is square root of 30 only. Square root of 30 is square root of 30. All right. Now the square root of 30, since 30 is not a perfect square, its value, this value will be the value of root 30 will be a non-terminating, non-repeating decimal. Why? Because it does not have a P by Q form. Because even if you write root 30 as root 30 by 1, this is not an integer. It should have an integer by integer form. Root 30 is not an integer. So if it does not have an integer by integer form, it's not a rational number. Then it is irrational. It is irrational. The value of root 30 is a non-terminating, non-repeating decimal. And so this is irrational. Now, supposing you have, say, like 3 root 7 into root 7. Is this rational or irrational? You must first simplify. What is 3 root 7 into root 7? Root 7 into root 7 is 7. And 3 7 are 21. And 21 is 21 by 1. Integer by integer. It's a rational number. So this one is rational. This one is rational. Do we understand, children?
Yes, ma'am.
Similarly, if you have, say, cube root of 25 into cube root of 25 into cube root of 25. All right. So now this will be cube root of 25 into 25 into 25. So from 3 25s, because it's cube root, no? So from 3 25s, 125 will come out. And 25 means 25 by 1, integer by integer. It's a rational number. It's a rational number. So this one is rational. This one is rational. Supposing you have, say, like square root of 128 by square root of 2. Supposing square root of 128 by square root of 2. Somebody's mic is enabled. Please disable your mic. So this is nothing but square root of 128 by 2. Square root of 128 by 2. Now you can simplify. 2 1s are 2 6s are 12, 4s are. So there's nothing but square root of 64. And we know that the square root of 64 is 8. And 8 means 8 by 1. P by Q, integer by integer. So this one is a rational number. This one represents a rational number. So what am I trying to say? When the heading is classify as rational or irrational, the heading will be classify as rational or irrational. For this, you should always simplify and then you must give your, conclusion. You should not decide before simplifying. Just by looking at 128 by, square root of 128 by square root of 2. Okay, now this looks like irrational. Okay, so this is irrational. It's not like that. You must simplify. How to simplify? Square root of 128 by 2. So you can simplify like this. Root 64, it's 8, 8 by 1, a rational number. So today what we understood is to simplify expressions. To simplify expressions. So you have to check if they are like surds or unlike surds. You understood that like surds can be added and subtracted. Multiplication, division can be done with anything. And then you also understood how to simplify expressions using identities. Next, so we started with simplification, simplifying expressions, simplifying expressions. Like root 7 plus root 7 plus root 7, you understood it as 3 root 7. So simplifying expressions we did. Then we simplified using identities. Simplify or we simplified using identities. Identities. Next, we learned how to express a terminating decimal like 125.125 terminating decimal or a non-terminating repeating decimal. We understood how to express both in the P by Q form. We understood how to express both in the P by Q form. And finally, now I told you very quickly how to classify expressions as rational or irrational. How to classify expressions as rational or irrational. Always simplify. Rational means it should, okay. Now class, tell me, is this rational? Is this rational or irrational?
Rational number, ma'am.
Why?
Ma'am,
Why?
because it has terminating decimal digit, ma'am.
It's
With
not a terminating decimal.
I mean,
It's a
non-terminating.
non-terminating repeating decimal, because this is nothing but 4.15 recurring. It's a non-terminating repeating decimal. But anyways, it has a P by Q form, because we know that a non-terminating repeating decimal has a P by Q form. So this is rational. So this is rational. 4.151515. There's a difference between this and this. There's a difference. This one is a terminating decimal. This one is a terminating decimal. Why is it a terminating decimal? Because it ends here. 151515151515151515. That's all. 15 does not go on forever. 15 does not go on forever. It stops there. That's a terminating decimal. But when it is 4.151515, and if you see these dots, it's nothing but 4.15 recurring. That means 15 goes on forever. So this is the terminating decimal. The first one is a terminating decimal, while the second one is a non-terminating repeating decimal. But both have a P by Q form. Both of them have a P by Q form. The P by Q form of this one is different from the P by Q form of this one. This one has a different P by Q form. This is different, but both have a P by Q form. Why? Because this is terminating, this is non-terminating, repeating. Both have a P by Q form. Their P by Q forms are different. They're not the same. So since both of them have a P by Q form, this is terminating, this is non-terminating, repeating, but both of them have a P by Q form. Both are rational numbers. Both are rational numbers. Now consider this 3.106, 107, 108, like this it goes on. Now, you don't understand the repeating block at all. It's like 106, 107, 108. That means it is 106, 107, 108. Probably it is 109, 110, like that. It goes on forever. So this one is a non-terminating, non-repeating decimal, because there's no repeating block here. So this is irrational. This is irrational. Consider this. Some 113.11, 12, 13, 14, 15 goes on like this. You don't see a repeating block here. You don't see anything repeating. So this one is a non-terminating, non-repeating decimal. So this is irrational because it does not have a P by Q form. Whenever the decimal is a non-terminating, non-repeating decimal, it is an irrational number, which means it does not have a P by Q form. So you should be very careful while classifying as rational or irrational. If it is a terminating decimal or a non-terminating repeating decimal, both of them have a P by Q form. So both are rational numbers, rational. If it is a non-terminating, non-repeating decimal, it does not have a P by Q form, and hence it is irrational. And also, when you have to classify as rational or irrational, you need to simplify and then comment. For example, if you're given square root of 100, the value of square root of 100 is 10. And 10 means it is 10 by 1, integer by integer, rational number. All right, children. So the notes based on these will be shared with you by tomorrow. Write out everything, all that which I send on WhatsApp should be written in your notebook. And that will be the assignment for the weekend. I'm not giving you anything else because that'll become too much for you. So complete your classwork, keep it ready by the next class. All right, children, is that understood?
Yes, ma'am. Yes, ma'am.
Okay, ma'am.
Yes, ma'am.
All right, children. All right, children. So that's it for today's session. Thank you so much. Good night. You may leave the call.
Thank you.
Thank you, ma'am.
Good night.
Thank you. Thank you, children. Good night.
Thank you, ma'am.
Thank you. Good night.